Srilekha, Department of Chemistry. Today I am going to take about on the topics of polymers. So now the recent technologies based on this polymers is nothing but the branching of polymers. Polymer means the poly means many and mer means the units, that is the one repeating units, it is called as a polymers. So here the polymers which is combined with the functions of a monomers. Monomers is nothing but it is in the form of repeating units of the monomers is called as an polymers. So the Greek word which combines from the polymer, it is called as a polymers. The poly which is repeating units and mer monomer also, which is the form of number of repeating units, and N is the degree of polymerization. The N is number of repeating units by the total number of units per the monomers. This is called as a monomers and the degree of polymerization. So the polymers which is classified into several types of polymers. Here we have the organic polymers, synthetic polymers and the industrial polymers and engineering polymers. So here we have using the first polymer synthesis method is a polyethylene. So the polyethylene type is nothing but polyethylene. So in the name itself we will know that monomer of ethylene is a monomer of polyethylene is a ethylene. So in this we have the functions group of PE. In this the polyethylene which is combinations of the polycondensation reactions to form a ethylene into a polyethylene. So there are the two types of polyethylene. One is a LDPE, that is low density polyethylene, and the another one is high density polyethylene. So low density polyethylene which is nothing but it should be in a linear polymer with branching and it has a 1000 to 3000 atmosphere range. In this we have the temperature about 80 to 350 degrees Celsius using benzyl peroxide as a catalyst. So in this it is by using the linear polymer, only the CH2 groups with the linear and it have no with branching items. We can add branching materials of fluoride, hydroxide and the metal oxides in this LDPE functions. So it is, I have given this example of monomer, that is ethylene, NCH2 double bond CH2. So here the NCH2 double bond CH2 which gives the monomer of ethylene NCH2 double bond CH2 under the polycondensation reaction with benzyl peroxide as a catalyst, and with this reaction it reacts with this polycondensation reaction. The double bond breaks up into one single bond and it functions as a CH2 bond CH2 and the whole form of the N. N is the number of repeating units, that is the degree of polymerization in this which converts the ethylene into a polyethylene with the breakages of the double bond into a single bond structures. So this is the LDPE functions, and the second one is HDPE functions which acts as a polyethylene. In the monomer of ethylene we are converting into a polyethylene, and with this the HDPE functions as a linear polymer and which has no branching units. So the linear polymer with no branching can be used in the high density polyethylene because it reacts with this polyethylene in the form of Ziegler-Natta catalyst. So Ziegler-Natta catalyst which has described about the functions of a ethylene group, that it has a n number of polymers, that is CH2 double bond CH2 under the reaction polycondensation reactions with the Ziegler-Natta catalyst to form the double bond structures which divides into a single bond structures and it forms as a polyethylene with the number of repeating units of N. So here I have NCH2 double bond CH2 in the form of a monomer, that is ethylene. The reaction which converts as a polyethylene, that is in form of double bond CH2 double bond CH2 will react with this polyethylene. So this is the types of polymer, how the low density polyethylene and high density polyethylene can be branching with and without branching, and by using this catalyst as a benzyl peroxide as a catalyst and Ziegler-Natta as a catalyst. By using this application we have the properties about this low density and the high density polyethylenes. So the low density polyethylene and high density polyethylene, it has a more density and the tensile strength and the tensile structures and with this flexibility. So tensile structures which has the LDP has a more tensile strength which is compared to the HDPE. So that is density is 0.92 and 0.95, 107 to 120, 85 to 136, and the flexibility which is more flexible, and the HDPE is more rigidity. And the application we are using in polyethylene is we are using in this food packing containers and the rushed bottles. Based on this packing material, it is used as a polyethylene. Thank you.